Matt Tinker with the rapido meter. These are the bits that I made so far for a homemade rapido meter. These have all been cut out with an angle grinder, mechanical hacksaw, drilled on my ancient pillar drill, and tapped and threaded. So far, I haven't done any milling machine work because I work in a rather in the way that anybody in steel construction works, which is put things together, tack them together, drill them, take them apart, and work on from there. I'm not particularly worried about having a super finish on everything. It's just I want to get it done. I bought myself a 3-foot square, 91 centimeter surface plate, granite surface plate, and I want to be able to do something concrete to be able to test it out. So this is the rapido meter that I'm making at those ends. I'll reassemble it. Now, this is a strange assortment of bolts because I'm working with what I had, and the positions of the screws are so that they don't interfere with other holes. I've drilled out, ready for to put the ball bearings in, as per Tom Lipton's very good mechanical precision video, which he released last week. I'll include that in the description, I think. I also had a look at John Sanders' NYCNC video on the beginning of his cooperation with Tom Lipton. This is it's interesting because I'm following some of Tom Lipton's ideas, but not all of them. I see that I have 2 bolts. One bolt is coming through to the other side. I actually put the bolts in place, put the bolts in and cut them off with a small cut-off wheel rather than cut them in the lathe or something. I'm very much in steel fabrication mode rather than the machining, because this is something I'm going to use on my own surface plate, maybe on other people's, I don't know yet, but it's not going to get excessive use, and it's a sort of, if it ain't broke, don't fix it kind of thing, where I just do things to a minimum of my needs. Now, so that is the base. The front hole where the ball bearing goes in the other side, I've drilled and tapped to M6, which may be a mistake, but we can always drill it bigger. This plate here, which is held in by 4 bolts holding the top on, this has a hole that I drilled in it for 480, which I think is a bit small. And the top plate is drilled for 6 by 100. This was, I was going on Tom Lipton's interesting ideas about making a double screw for the fine adjustment. And he was using a quarter 26 and a quarter 26 and 10/28. So that the difference between the threads was only two TPI, which when I started thinking about it, yeah, I'd taken 6mm as being close to a quarter. But there is something that I hadn't thought about, which is that, working in the metric system, the difference between 4mm 80 pitch is 0.2 of a millimeter. It's 475 actually, not 480, and it's 0.2 of a millimeter. So if I have a difference of 0.2 of a millimeter between the two threads, 25 hundredths of a millimeter between the two threads, it doesn't matter if the big thread is 10 millimeters 150 and the small thread is 8 millimeters 125. The difference between the two is going to be the same. So I don't see any point. I don't see any advantage in using smaller. I think I've got this middle plate in the wrong order, but it doesn't matter. I don't see any advantages in using the smaller size threads here. And as I'm going to make this a flexion joint in this top piece, I would prefer that had a big thread that was capable of holding this in place as well as adjusting, rather than having a small one, which seems rather flimsy to me. So this is the dial gauge that I've got so far. Yes, I've got something in the wrong place, I think, but it doesn't really matter for the moment. This is a 1 micron dial gauge, which I got for €18 plus €6 postage, which is about, which is less than $30. I actually got two. I got another one at 14 with €6 postage, which is, it's just really silly. But people don't realise that 0.1 and 0.1 or 0.01 make a lot of difference to a dial gauge like this. So I'm not taking Tom's advice to drill it bigger, because I can get more of these quite easily, and I will end up having one that's dedicated to this tool. So the Micron gauge is really quite something. They're readily available, and they're readily available because I'm in metric France. Okay, well, that's as far as I've got so far. I've drilled this big hole because I'm going to slot it here and cross drill and thread one side and have clearance on the other side, so that I can pinch up nicely the dial gauge. I'm going to put a 6mm bolt with a nice flush top, nicely finished top in to have a rough adjustment to get the dial gauge in line. I see I've been doing this in the shadow, but I could have brought this a little bit farther forward. Yeah, but this is going to be a coarse adjustment to come up and down underneath here, The fine adjustment is going to come in here, which will be a wheel. And I'm probably going to use 10mm and 8mm threads to get a difference of 0.25mm between the two. It's not... that would work out at something like 100 TPI, but the equivalent of 100 TPI thread, which is pretty okay by in my book, which will be sufficient for the really minimal movement that I'm going to make on this to adjust this tool. Okay, now I'll leave it there for the minute and get back to drilling these out and tapping them. I don't really think there's much point in going through painstakingly every little bit of this, because it's more about the overall making of it and the differences between what Tom is doing and what I'm doing. I'm not going to make the flexion joint that he made, because quite simply it's easier for me to set that up in the mill and cut it. I'm going to do the same sort of thing here. I might drill it first so that this part is then... I'd rather have a round edge than a saw cut one, but that I will see how I feel about it. Okay, so we'll move on from there. Well, I've made a little bit of progress. I did some experimenting with different size threads for the fine adjustment. I thought about it quite a lot, and I experimented using 8mm inside 10mm, which was actually just a little bit too close. The inner diameter of the 8mm was too close to the 8.5mm inside of the 10mm thread. It was just a bit too much like making helicoils. It was possible, but there was only a 1/4 millimeter wall on each side. So I went back to the 6mm with 4mm under here. The 4mm is 4mm by 0.75, which means that 4mm is the maximum inside the 6, which is 6 by 1.1. So the by a millimeter, sorry, 6 by a millimeter. So between the 4 and the 6, there's actually 0.5 millimeter per side, which becomes usable. The adjustment, although I still haven't made the flexion part, is extremely nice. So when I cut the flexion, I think it's going to be better. I'm not going to make a huge one, but there's a little tiny bit of backlash, but it's really minimal. So the 4mm inside 6mm is a difference of 0.25 millimeters between the two threads. So if I've got it right, that is equivalent of a 101 point something TPI thread, which is just fine for this application. It works very nicely. Down here I've got an ordinary M6 bolt that I've polished the head on. I hope it's not going to be smooth enough. I don't think that the left-right movement from here, because of the changing of the angle, is going to play is going to come into play very much. So this disc, which was the inside of a hole cut with a hole saw, the hole in the middle welded up and re-drilled, is going to get knurled and cleaned up and put in such a way that there's the lock nut is underneath, and that the top is flat and relatively smooth. So all I need to do now is to make the flexion here, flexion there, the support straps, because I've decided to do this using a saw cut, rather than going to the trouble of going through all the drilling and tapping and it's easier for me to just make a cut than to make a flexible plate to put in there. And I'll use the original plates on the side system for stopping it wobbling about. I've already drilled the holes underneath for the steel ball bearings that'll be going in there. They are 19mm, and at the moment they slide in. But what I'm going to do is I've got some shim stock, and I'm going to use that and press them in so that they lock in tight, so that I'm not stuck with something that... I did it this way because, to be quite honest, I was in a bit of a hurry, and it's quicker for me to drill that out and then shim it to be able to get it to lock it in place. But I don't think that's going to create much of a problem. It's interesting how flexible. I mean, those are 10 microns. So that's a hundredth of a millimeter movement there that I can get in flexibility in this 5 centimeter by 1 centimeter piece of cold rolled. Over that distance, it will. I'm actually not even sure that I need to bother to this is sufficient, is enough adjustment, because the experimenting with the course adjust underneath the it would have been perfectly feasible to use an ordinary 6mm thread for the fine adjust with that diameter of wheel on it. So I really don't think I need to bother to make a flexion in this bit. It will be stronger and would work fine, I think. Okay, so that's as far as I've got now. The next bit is going to be prettying up the wheel, cutting the flexion here. I'll maybe give it some there just to be kind to it, but I'm not sure that it's necessary. Cutting that flexion and putting the steel balls underneath it. Originally, I was going to make a knob for this screw. I'm not even sure that it needs it. If you tighten it with an Allen key, it's too much for it. So maybe just a little tighten it to stop it moving with an Allen key. If you tighten it too much, it has too much of it can crush the tube and stop the stop the dial gauge working. Okay, that's it. There we are for now. Okay, as with most things here, the steel ball bearings that I've used are actually second-hand ones. The holes that I've drilled for them are 19mm, and these are 19mm ball bearings. To compensate for this, I've found a bit of shim that works very well, which is actually they're 1800ths of a millimetre, which works out at about 1/7 side. So by pressing them in with these shims in the holes, I'm getting an interference fit, which should be reasonable. Okay, so I'll just put these two remaining ones that I have to press in place and press them in. So this is a somewhat wider view so that you can have an idea about how this is going on. It actually put a couple of dimples in the steel bearing in the lower plate, which is, I was sort of wondering whether it would do that. It doesn't matter, this is just a piece that I have as an offcut. So, the two 8mm drill bits back in place to allow me to press the bearing into 8mm without going. So I would like them all to be the same, which is a fairly reasonable sort of thing to want. Whoops, I haven't put the other out of the spacer in.
C'est pareil pour les oiseaux, donc c'est ce que vous êtes en train de nous dire, c'est-à-dire qu'il faut observer pour voir que certains ont disparu.
I never found the right sort of springs for this. It doesn't really matter. You can always push it back up by hand, but you have to push it back up by hand. Okay, so we've got the drill bits back in place and enough room to slide the spacer in. Let's just
au-dessus de nos campagnes et qui ont quand même, s'ils n'ont pas disparu, en tout cas se sont-ils raréfiés. Ils mangeaient de gros.
Make sure that
il faut toujours commencer par le commencement et tout ça.
Yes, feels a bit off center. Okay. And once again, didn't feel quite right on this. And it's a broken off drill bit.
Ça, c'est un cas de figure qu'on connaît tous. C'est vrai que, encore une fois, par rapport à ce qu'on disait tout à l'heure, c'est très difficile d'avoir une vision réelle, objective, quantitative des effectifs. On parle de pare-brise propre ou sale. Je donne une anecdote. Si vous avez au mois de juin 15 jours de sécheresse,
that one's tight.
le 16e jour, il y a un orage de
That's it.
et le lendemain du soleil, si vous prenez la voiture ce jour-là, 400 km, pare-brise.
Okay. That's a third all in place. Okay. And now for the fourth.
Alors que ce soit pour les oiseaux, pour les insectes, pour plusieurs mammifères, François Moutou, qu'on pourrait énumérer, on incrimine, quand on parle de
once again,
on incrimine l'extension urbaine, les activités
So here is another view of the slotting operation, which is not very exciting. It just goes on and on. I could probably run it faster, but I am not very experienced with the slitting saw, so I'm running it slow enough so that it doesn't chatter. Once I've finished this bit, I've got to cut a slot in the top so that, cut a slot in the top part so that the adjuster will have its flexible bit. Well, here is the completed rapido meter, which just needs a coat of paint. I didn't do anything about knurling the screw for here or knurling the edge of the disc. Just point out that this is a the adjuster has straight knurls, and everything that is gripped have diamond knurls, which is common practice. So I've made a knurled knob for the end of the screw here, because with an Allen key it was too easy to lock up the dial gauge. With the you can do it by hand, just with the knurled knob, but it's much less likely to do any damage by crushing the dial gauge itself. As I said before, this is I've made this to an 8mm shaft size, which is standard dial gauge of this kind. I have two of these 1 micron definition gauges. I just thought I'd look for a few more, see whether I just got lucky, and apparently I got very lucky and found myself with two that weren't expensive. I'm going to keep on looking out for them, because it's quite useful to have the extra precision. As far I made two anti-droop bars, these things on the side. Initially I was going to make them with kind of little top hats, so that the bolt would be holding a top hat against the frame. But I realized that this is rapido meter, finished, painted, and ready to go. There's not much contrast, so I'm curious to see how much is actually visible on the video. Okay.